Hello, we're conducting a presentation of a paper with title GS-WGAN, a gradient-sanitized approach for learning differentially private generators. In this paper, we tackle the problem of high-dimensional data generation with differential privacy guarantees. We propose a gradient sanitization approach for training GANs, which sanitizes different gradients done in previous works and allows us to exploit the theoretical property of Wasserstein GANs. This brings several benefits, such as easier hyperparameter training and more stable training. Also, it applies seamlessly to both centralized and federated setting. Moreover, extensive experiments results show that our method achieves consistent improvement over previous works. Our work is built on top of recent progress in privacy-preserving data generation based on GANs. Existing works typically applies differentially private stochastic gradient descent in training the GANs. In comparison to the vanilla GAN training, DPSGD first sanitized the gradients before performing the update step. This includes clipping the gradients and adding calibrated random noise. However, selecting a proper clipping bound is difficult in practice and requires intensive hyperparameter search while introducing high bias as well. To address this limitation, we propose our framework based on the insight that only the generator needs to be released, while the discriminator is not required for inference and will not be published. We then propose to selectively apply sanitization only to the gradients transferred to the generator, while keeping the discriminator trained normally. This helps maximally preserve the gradient information. Moreover, we exploit the Lipschitz property of Wasserstein GANs to derive the optimal clipping bound, which bypass the hyperparameter search process while introducing a much smaller clipping bias. Our method is easily applicable to the decentralized setting, where each user trains a discriminator on its dataset locally and only communicates the sanitized gradient to the server. Our framework provides user-level DP guarantees even under an untrusted server assumption, and is more communication efficient than the previous method. To validate the applicability of our method on high-dimensional data, we conduct experiments on image dataset and evaluate the privacy costs as well as the sample utility. Here we show the quantitative comparison. We observe a significant improvement in terms of the sample utility, and we show the improvement is consistent when considering different datasets, evaluation settings, and across all metrics. Qualitatively, our method also generates samples with better visual quality in comparison to baseline methods. For more details, please refer to our paper. Our source code and models are available on GitHub. Please visit the website for more information.